Now, in that particular part of the study, we will discuss about the specific resistance. Now, you know what is the resistance. So, resistance is the hindrance in the flow of current inside of any conductor. And if we are just choosing a particular resistance, which length is fixed, which area is fixed, and it must to be one unity, 1 मीटर लेंथ हो और क्रॉस सेक्शनल एरिया भी उसका 1 मीटर स्क्वायर हो, तो उस पर्टिकुलर कंडक्टर का जो रेजिस्टेंस होगा उसको हम उसका स्पेसिफिक रेजिस्टेंस या रेजिस्टिविटी कहते हैं. जिस आपने क्लास 10th में पढ़ा भी था कि if you are just applying a particular potential difference with the help of battery in that particular conductor like that, and you know very well in that particular situation if its length is unity and area is unity, then its resistance, you can find the resistance with the help of V by I. So its resistance will provide the specific resistance of that particular conductor. वही बात यहाँ समझा रहा हूँ. लेकिन एक न्यू डिफरेंशिएशन भी है इससे जो आप 12th में पढ़ रहे हैं कि सपोज दैट पर्टिकुलर कंडक्टर इज कनेक्टेड विद द बैटरी और सेल, एंड यू नो वेरी वेल फ्रॉम पॉजिटिव टर्मिनल टू नेगेटिव टर्मिनल इलेक्ट्रिक फील्ड सेटअप होती है नहीं, बताया था मैंने प्रीवियस लेक्चर में. एंड इन दैट पर्टिकुलर कंडीशन करंट पर यूनिट एरिया इज नोन एज द करंट डेंसिटी, यू नो. तो रेशियो ऑफ द इलेक्ट्रिक फील्ड अप्लाइड by current density, ratio of the electric field by current density is known as the specific resistance or resistivity of this one conductor. It is a new definition of it by which you can calculate the numeric problem and just find the formula of it. जो फार्मूला हमने डिस्कस किया था अभी R इक्वल टू रो एल बाई ए, वो कहाँ से आया उसकी हम डिस्कशन करने वाले हैं. तो फाइनली आई वांट टू टेल यू here resistivity of specific resistance is given here, and in that particular condition resistivity of material of a conductor, resistivity is the specific property of the material. अगर material change कर देंगे material resistivity of that particular material will be changed. So in that particular condition resistivity of material of conductor is defined as the resistance of the conductor of the length 1 meter and area of cross section 1 square meter. If length is unity and area is unity, then its resistance is known as resistivity and its unit भी ohm meter. ये तो आपकी definition वही है जो क्लास 10th में आपने पढ़ी थी. But finally, or we can also introduce here ratio of electric field intensity, it is vector quantity, and current density, it is also vector quantity at any point inside of this one conductor. This one conductor is also known as the resistivity of that particular conductor. तो ये फॉर्मूला तो आप जानते ही हैं, R equals to rho L by A. Okay, and in that particular situation, if L is 1 meter and A is the 1 meter square, then you know very well rho R must be same. R is equals to rho and its unit becomes ohm meter. क्योंकि ये आपका you know very well length will be meter, rho is written as the R A by L, so it becomes ohm meter square by meter cancel out, it becomes ohm meter. You clear now? तो इसकी यूनिट भी निकल कर आ गई. And finally you know very well in that particular condition if we will find the result here, तो एक ऐसा कंडक्टर जिसका लेंथ भी 1 मीटर है, एरिया भी, तो you can say it is like a cube. जरूरी नहीं को क्यूब हो, but it can be like a cube and it can also like a cylinder. तो you know very well इसका जो क्रॉस सेक्शनल एरिया A है और इसकी जो लेंथ L है, it must to be 1. ओके, तो ये आपका अगर इस पर कोई पोटेंशियल आप अप्लाई करते हैं एंड फाइंड द करंट, तो रेशियो ऑफ द पोटेंशियल एंड करंट विल प्रोवाइड द रेजिस्टेंस और वही रेजिस्टेंस इसकी रेजिस्टिविटी होगी. फाइनली in the note form I want to tell you note number 1 and note number 2, there are two different points. So you know very well in note number 1, you know according to the new definition, second definition, rho can also be defined as the ratio of the E and J. Okay, and you know very well पीछे आपने पढ़ा था in the relation potential gradient बोलते हैं आप इसको. Okay, so in that particular condition it is known as the E equals to V by L, and अभी स्टडी किया आपने current density J is known as the I by A. So finally we want to write the value, so rho equals to V over L divided by I over A. It can be written as the, you know very well, V over I in that particular bracket, and it becomes V by L. So it will be A by L. Okay, and that particular term will indicate the ratio of the potential and current is known as the resistance. So it will be RA by L. So what should be the result? You know very well, rho becomes RA by L और R becomes rho L by A. तो ये आपने फॉर्मूला प्रूफ कर दिया जिस फॉर्मूले को आपने यूज किया था. And at the last of the study of the ohms, I want to introduce you two different new term, conductance and conductivity. So you know very well it is just reciprocal of the resistance and resistivity. Resistance तो पढ़ा था ना, resistivity पढ़ लिया. तो you know very well what is the conductance. The inverse of resistance is called the conductance. इसको symbol जो है capital G से represent करते हैं, reciprocal of the resistance. And unit भी ohm inverse. It is also known as mho. It is known as a mho. Okay, but written as the OHM ohm. अब इसका रिवर्स लिखेंगे तो MHO is written as the mho. रीड करते हैं mho but लिखते हैं MHO. At the condition it also known as the Siemens. Siemens is the name of the scientist. Ohm was also name of the scientist. So it will be known as the Siemens. And now you know very well conductivity, reciprocal of the resistivity. The inverse of resistivity is known as the electrical conductivity. And you know very well its symbol is the sigma, nu or sigma. It is known as nu or sigma. Okay. So here you know very well sigma is written as the 1 by rho and its unit becomes, you know very well, rho की unit क्या थी? Ohm meter. तो ohm inverse, meter inverse. Okay. And it can also be written as the Siemens inverse. Clear? So now you know what is the ohms and now you know very well what is the resistance as well as its values as well as the resistivity and some other concept of the conductivity and क्या बचा? Resistivity, conductivity, resistivity, conductance, resistance. All are similar and very easy to understand. Okay. In the next part we will discuss combination of the resistance and proof of the Ohm's law. Okay.